Hello friends, I hope you all are doing good. So in this lecture, I'll be discussing the third question of my data science second internal examination. So the question says, give an algorithm for linear classification model least square principle for fitting a best fit linear curve in scatter plot. So we have to write the algorithm for linear classification model using the least square principle. So begin. First is data preparation. Collect a data set of n samples, each with d features, independent variables, and one target variable dependent variable. Represent the data set as a matrix X of size n into d and a vector Y of size n. Add bias term, a column of ones to the feature matrix X to get X of B size n into D plus 1. Compute the weights W of size D plus 1 using the normal equation. W equal to X into X to the power T into X to the power B whole to the power minus 1 into X into again x to the power t into v, where x underscore b power t is the transpose of x to the is the transpose of xb. Then we have to define the linear classification model as a function of x, in which the w to the power t into x, where xb is the feature vector in the with the bias term. Now make the prediction. Use the model to predict the target variable for a new feature vector x. Y prediction equal to fx equal to wt into xb. If y prediction is greater than a certain threshold, example 0.5, classify the sample as positive, otherwise classify it as a negative. Example use case. Suppose we want to build a linear classification model to predict whether a person is likely to buy a car based on their age and income. So we have given the age of a particular person and the income and the particular number of car he has bought. So the age 25, income 1, 2, 3, 4, 50,000, bought not a single car. And the person having age 30 and income 60,000 have bought a car. And the person having age 35, income 70,000 also bought a car one. We can use the algorithm of to compute the weights W and build the linear classification model. Now we'll see the code implementation. Here's a Python implementation of the algorithm using NumPy. First, we have to import Python NumPy and then define linear classification x comma y, add bias term xb equal to n using the hcheck methods and computing the weights. And then we have returned the W, the data we have, the variable we have made. And then we have to predict the weight and the x measure using the predicted target variable, and then we have to return the predicted target variable. Next is the example usage. X equal to, we suppose we have array of the particular person age and income, and then we have classify the car bought as 011, and by using the linear classification x comma y, we have put in a new variable x new equal to np dot array 40. We are predicting for a person having age 40 and income having 80,000 whether he will bought a car or not, and print the predicted target variable y prediction. This implementation defines two functions. Linear classification computes the weight w using the normal equation, and predict uses the weight to predict the target variable for a new feature vector. The example uses demonstrate how to use this function to build a linear classification model and make predictions. So guys, I hope you understood the video. This is all from the lecture. Thanks for watching. Bye.